is one of the most rigorously studied set of techniques in the history of machine learning. Continuing on our journey of exploring classification algorithms, let's explore a couple of more classification techniques as we know. The next category of classification is known as KNN classifier, also known as lazy classifier. Why KNN, which is also known as K nearest neighbor classifier, is also known as a lazy classifier is because in this case we do not generate a model. We do not generate a model. Instead, what we say is, suppose I have a set of points, two classes, say x and plus. You take any point which you want to predict the class for. So let's say we are talking about this one. What we do is, let us fix k. K is something you have to fix. Let's say k equal to 3. Then KNN classifier says that look at k of its nearest neighbors. And take the mode of the class of its neighbors. Mode means whatever is occurring maximum number of times. So for example, if k equal to 3, we want to say, look at this point, we find the nearest points are 1, 2, 3, right? So these 3 points all are basically pluses. So naturally the class for the point is plus. So that is a very simple illustration. Suppose we have something which is, talking about a point here. Here 2 points are x's and 1 point is plus. So there the point becomes cross because majority 2 out of 3 are crosses. So here we are not generating any model, but instead we are looking at a way by which we are talking about the majority class among all its neighbors. Given the majority class here is dependent upon what its actual neighbors are and the notion of distance, it is important to understand what is the distance function which is used to compute the distance between any 2 points, and that becomes the criteria for how you define nearest neighbors. Distance can be measured in multiple formats. It can be Euclidean distance, Manhattan distance, Descartes distance, or it can be Eric distance or cosine distance. There are several variants of distance which have been proposed in the statistical history and used in the context of machine learning. So as you see, KNN classifier is a very simple classifier where we do not actually compute a model, we are lazy and compute the actual class based on the notion of distance and nearest neighbor when you get an actual new input. Going beyond KNN, a fairly popular and a kind of, I would say, good discovery in the history of machine learning has been the notion of support vector classifiers or support vector machines and using support vector machine for classifiers. In the context of support vector machine, it's a very simple concept. The idea is you take a set of data points. Let's assume you have data points like this. So suppose we have a very simple separation of this by means of a straight line which is separated. So can we answer that this is a good candidate classifier for separating these two classes? I would say yes, because it's able to separate them both. But then I come back and say that I will create another line which is like this. Even this line is able to separate out both set of points into two separate classes. So in that sense, we can actually have several linear classifiers separating two classes. But then, is it possible to have one classifier? The answer is no. We can have infinite number of such straight lines which qualify as potential classifiers for this two sections separate. So that is why we concentrate on what is known as maximum margin linear classifier. So when we say maximum margin linear classifier, it's actually a band which is rectangular, which consists of infinite number of tags within it, and which is bounding, and it's like a rectangular region, which is able to separate out both the regions. This band is called the maximum margin linear classifier. But the idea is, if you talk about a real line and you want to see what is the bounding line of such a maximum margin linear classifier, it's very difficult to establish an exact line unless you specify points on that. That is why the definition of a proper separator for or a classifier for these two is only complete when you can specify the band, or which is also called margin, plus boundary points on either side which fall on the actual line. So we have these 2 points, for example x and x, let's say here we have 1 point, and these 3 points which are plus on the either side of the boundaries. So these points are called the support vectors. So point is, when we say a support vector machine or a support vector classifier, the classifier consists of the maximum margin linear classifier band plus the points on the boundary of both sides called support vectors. This together forms the classifier which is able to separate out both classes into 2 separate classes. SVM has one disadvantage, that it can only do binary classification into 2 separate classes. So SVM is very powerful in several contexts of classification. In history, it can be used for classifying images, classifying a lot of unstructured data, as well as several structured data. So you can say, in terms of classification, this is one of the revolution in terms of conventional machine learning.